I think this part is clear. Now let's take up the example itself. This particular question, let's take that itself as our example. Okay. Suppose you are asked, man, some object is placed over here, right? Maybe some wire is there in this way. You're asked to find out what is the diameter of this particular wire, right? The data given is that over here the pitch is nothing but equal to 0.5 mm and the total number of circular scale divisions is nothing but equal to 50 mm. Okay, okay. And if this is the case, find out what is the reading now. It's different from the earlier diagram. Okay, it's not 100 circular scale. Why did I write 50 mm? Oh my god, that is also revealing. Okay, total number of circular scale divisions is nothing but equal to how much? 50, right? Okay, so therefore, how much is the reading is? Please take your time. Please pause the video and get back over here. Okay, okay. So therefore, let's go to the solution now. Now, reading is nothing but the main scale reading plus the circular scale reading, right? If you look at the if you look at this uh, sleeve over here, right? You can notice that each smallest division over here, right? It corresponds to 0.5 mm over here, let us say. Yes, and this one over here will correspond to 1 1 mm over here, correct? So therefore, what is the main scale reading? Since each is 0.5 mm, so 5 are over, so 5 mm is done. Then plus this one more small division, which means 5 plus 0.5, which is 5.5 mm itself, right? Plus CSR is nothing but n multiplied by the least count, right? Okay, we want to find out the least count. Least count is nothing but how much pitch divided by total number of circular scale division. Be careful with this, right? Here the pitch is not 1 mm, here the pitch is 0.5 mm, right? So this is 0.5 divided by total CSD is 50, which means how much is that? And this is an mm, right? We get 0.1 by 100, which is 0.0. One, correct? 0.01 mm is the least count, right? And how many divisions are coinciding over here? Of the which division is coinciding over here? You notice the 12th one. That's all. So therefore, now you can directly write that circular scale reading is nothing but 12 into 0.01 mm, and therefore this is nothing but 0.12 millimeters, and therefore the reading is nothing but equal to how much is that? This was 5.5, right? Plus 0.12 mm as a whole, right? So this becomes equal to how much? 5.62 millimeters, right? Now this part I think is clear, no doubts are there, right? See, normally the smallest uh, main scale division itself is nothing but the pitch. Normally, not always, right? In this case, it is true. So 0.5 mm is the pitch, not 1 mm. And over here, as you can see, this is the data given. Okay, this is done. Okay, ma'am. So now let's move on to the zero error. Let's move on to the zero error, right? So as we have seen in vernier caliper, the zero error is of two types. It could be positive zero error, it could be a negative zero error. Okay. Now let's look at this particular diagram. Okay. So you can see that this is nothing but the anvil over here, and this is the lead screw over here. They both are in contact, right? So if they both are in contact and nothing is, therefore, there is no object present, right? So, uh, therefore, let's look at what the readings are being shown by the device. Now, because of manufacturing defects, these errors are also called systematic errors. All these manufacturing defects, right? They are not random errors which are uncontrollable. They are systematic errors, and you can actually eliminate them because they keep repeating themselves, right? Systematically. So, in your calculation, with the help, you can rectify them. Okay. So, what reading is being shown? Zero division is visible on the main scale. So, MSR, normally MSR will be this one. Okay. What about the circular scale reading? Is that showing you the zero of this one, of the circular scale? Is it below? Yes. Ideally, what do you expect? The zero mark over here and this zero mark over here, right? But if the zero is actually below, it means that this device is showing you a reading over here, right? How many reading it is showing you? 5. So, therefore, the circular scale reading is nothing but 5 multiplied by the least count, right? Right. So, therefore, over here, CSR is 5 times of least count. Now, why also this 5 we are saying, right? Because that's what it is being shown. And if you were to put an object over here, what would then happen? Let's say that you put this object. How will you open uh, the jam bottle? By rotating it this way. So will this 5 on rotating the screw, will it go up or will it go down? Which way this 5 will move, man? The 5 is going to come down. So no, 6 will be shown. 7 will be shown, right? It means it is showing you exaggerated value because it's not really 6. It is just least count value, right? It's not 7, it's just 2 times the least count value, the actual object measurement. So over here, whenever the 0 is below the reference line, we say that the zero error is nothing but a positive zero error. If you take the division coinciding as m, you just write m multiplied by the least count. This is your positive zero error. And the true reading or the true value is nothing but the shown reading. After you find out the shown reading, just like you found out in the earlier one, you just have to subtract the zero error. You be careful that the zero error over here is positive. You are subtracting the zero error. Why? So that you don't get the exaggerated value, you get the actual value. Therefore, you have to subtract the zero error. Okay. Okay. So now let's take the case of a negative zero error. Right. Now the negative zero error is such that the zero on the main scale is no longer going to be visible, ma'am. Yeah. So the situation will be in this way. Zero is not visible. And what about the zero on the circular scale? The zero on the circular scale will be found above the reference line over here, right? If this is the reference line, some distance above it will be found. Okay. So how will it appear? In this way, it will appear. You will not see the zero at all. So if there are 50 divisions, maybe the 45th division is the one that will be present over here along the reference line. So does it mean that the least count, does it mean that the zero error is is negative is negative 45 into least count? No, no. Now you open the jam bottle again, rotate it this way. So what will happen to this particular 0? Will it go up or will the 0 go down? Yes, it actually goes down. So as it goes down, this particular 0 of the main scale will now be visible, right? So now you have actually created some space over here, right? How much was the space that you created over here, ma'am? Cool. Just wait. Your call only is that. Wait, ma'am. हेलो. हाँ बोलो. मैं तुम्हारा ही रिकॉर्ड कर रहा हूँ. हम्म. हम्म. हाँ. Okay, so this is the moment when you called. Okay, so this is nothing but the what is this? Wait, I'm so what I was saying. Okay, so when you opened this one, you moved the you moved on the circular scale by how many divisions? Totally, there are 50 divisions, right? This means that 5 divisions you moved the 0 down. That means this gap that was created is equal to the moment of 5 divisions on the circular scale. And each division is of least count. That means 5 into least count has been moved, right? So in this case, the zero error is not 45. Okay. In this case, the zero error is just the difference between 50, the total CSD, and 45. Okay. And this is a negative zero error. All right. So therefore, over here is nothing but the total CSD minus the mark which is being shown into the least count. Okay. So how much is that? This is nothing but equal to minus of 50 minus 45 into the least, whatever the least count that you find out from the pitch data. So you get this as uh, uh, this particular value, right? I hope this part is clear. No doubts are there, yes. And again, what will you do for the true value or the true reading? This is nothing but equal to the shown reading, right? And from this you will subtract the zero error, right? Zero error itself is negative. Be careful with that, right? Okay, this part I think is clear. Yeah. Okay, now moving on to some problems. So what you do, just take the printout of these pages. I'll send you the screenshot. You just give it to Nate sir. And because how will you draw all this is difficult. So in that few problems you just give it and you just solve it in class in front of him. All right. Now solve this question, man. In an experiment to find out the diameter of the wire using the screw gauge, the following observation were noted. Okay. S- Screw gauge moves 0.5 mm on the main scale in one complete rotation. Total division on the circular scale is 50. Okay. Main scale reading, they have given you main scale reading. 45th division of the circular scale is in the pitch line. Okay. Instrument has 0.03 mm negative zero error. Okay. You are asked to find the diameter of the wire which is being measured. So pause it right now. Yeah. Now we are going to discuss the solution. So uh, they have given you the main scale reading, right? So and the negative zero error. What more you want to do over here? Nothing. It's nothing actually, right? And this was JEE main question. Okay. So you write over here uh, the true reading is nothing but the shown reading minus the zero error. Okay. So for the shown reading, we need actually some pitch data, right? And the least count data. So the least count over here is nothing but pitch. Pitch is how much? 0.5 millimeters divided by what is the total CSD? 50. So you should be getting 0.01 mm, right? Yeah. And therefore, the shown reading is nothing but equal to on the MSR how much? 2.5 plus which division is coinciding? 45th, right? So 45 into least count is 0.01. So you get this as 2 point, is it 9.5? 0.50 and 0.45. This is in mm only. So be careful while doing the calculation. Right? Take your time. 2.50 plus 0.45 mm. So 2.95 mm is the shown reading. And how much is the zero error? ZE. Is it negative? So you put one minus sign. Now. This is minus 903 mm. And now you just plug it in this formula that we saw. So the true reading is nothing but shown reading, which is 2.95 minus of minus 0.03 mm. So 2.98 mm. That is the correct answer. This part I think is clear now. Yeah. Okay. We move on to the next one. Yeah, all these three, four problems, you just take the printout and give it to him, right? So that it will cast a very good impression that you have taken this very seriously, and yeah, he won't cause any more troubles. Okay. So do this. Read the question number 91 and you just do that. Okay. Pitch. You can pause it also. Okay. So pitch and the total divisions on the given is 0.5 mm and this. So from this you find the least count data. The least count is 0.005 mm. Yeah. 0.5 by 100. Okay. When this screw is finally to zero, the zero of its circular scale lies three divisions below the main line. Okay. So here it is. So three divisions uh, below the zeros, right? So that means this is the third mark. Yeah. Is this a positive zero error or negative zero error? Yeah, it's showing an exaggerated value, which means that the zero error is positive. So it is plus 3 into LC, which means that it is 0.015. Okay, this is your zero error. Okay. Hmm. और क्या चाहिए? The readings of the main scale and circular scale of this is no, that's all. Are they have so now let's find the reading. So the true reading is nothing but shown reading, which is 5.5 mm plus 48th division into the least count, which is 0.005 mm, and minus the zero error, which is minus 0.015. I hope one of the option matches. Okay, so 5.5 mm. ये कितना है यार? 48 इंटू पॉइंट इसका मैं क्या करता हूँ, इसका आधा कर देता हूँ, ठीक है? सो 28 है ना, चाहिए ऐसा मेरे को लग रहा है, ठीक है? सो अगर ऐसा है तो ऐसा ही होना चाहिए, नहीं 28, सॉरी अच्छा 48 का आधा 28 नहीं है क्या? ओ माय गॉड, ठीक है, माइनस 0.015. ओके, सही है इसको करके। अरे यार 48 into 5, अच्छा तो 290 आ गया क्या? शिट, गड़बड़ हो गया, हमने थोड़ा सा गड़बड़ हो गया, ठीक है। 48 5 टाइम्स तो हाँ 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 हाँ, ठीक है 290। अरे यार कैनवस नहीं बिगड़ना चाहिए जरा। वो दूसरा क्वेश्चन एक्चुअली। ओके, इसमें यहाँ पे क्या है, 290 है ना, एंड माइनस 0.015। कितना आ रहा है मैम? आप कैलकुलेट कीजिए। हे भगवान, ये मेरे को पसंद नहीं है। This is like, what is this? This is 300, you'd say. So 5 point, कितना 7 तक जाएगा ना, 790 हो गया। 790 में से अगर हम 15 को घटाएं तो कितना आएगा? हम्म, अरे रुको यार, 240 है क्या? मैंने 290 पे लिख दिया मैंने। ठीक है ना, ये सब होता है, तुम मत करना ये एरर, ठीक है? ओके, सो हाउ मच इज दैट? 740 minus 15, that is 725। बाप रे, इसको करने के लिए थक जाऊंगा। दैट्स व्हाई स्टूडेंट्स को ही कैलकुलेशन करना चाहिए, वो लोग करने के बाद ना तुम निकालो। हाँ हाँ करो बेटा करो। अच्छा अच्छा बच्चा ने आंसर निकाल लेगा, हाँ ठीक है करके तुम बस उसको वेरीफाई करना, ठीक है। ओके, सो आई थिंक दिस पार्ट इज क्लियर। 5.725 mm. Okay, moving on to the next question. Okay, the least count of the main scale of screw gauge is 1 mm. LC